Hello class, this is Ms. Augustine. Today we're going to practice doing some thermochemistry problems, heat problems. Okay, so our first problem is asking us to solve for Q. How much energy. Whenever you see how much energy, know that you're solving for Q. And we're going to identify variables. So our M is 43.0, that's the mass. Our T1 is 11.5. Our T2 is 71.2 degrees. And so our delta T turns out to be 59.7 degrees. Now, our equation is Q is equal to mass times specific heat capacity times delta T. And off to the side here, remember that C for water is 4.184 joules per gram degree C. So let's go ahead and plug in our numbers. Q is equal to our mass, which is 43.0 grams, times our specific heat, 4.184 joules per gram degree C, and our delta T, which is 59.7 degrees C. So cancel units, degree C in grams. We're left with joules, which is what we want for heat, and our Q ends up being 10,740.7464. Thank you, calculator. And looking at our sig figs, it looks like we need 3 sig figs. So counting from the left, our third significant digit is the 7. The number immediately following it is a 4. So 4 and below, we let it go. So our number to 3 significant digits will round to 10,700 joules. And let's put a box around it. And we're done. For problem 2, we're asked to solve for specific heat capacity, which is the variable C. So identifying variables, M, our mass is 55.8 grams. Our Q, heat, is 7,500 joules. And our delta T, when we look at our T2 and our T1, delta T is always T2 minus T1, and in this case that's going to be equal to 50.5 degrees C. So rearranging our equation, we'll know that C is equal to Q divided by M delta T. Think about the definition. Specific heat is joules per gram degree C, so that works out. And now plugging in our numbers, our Q, recall, is 7,500 joules. Our mass is 55.8 grams. And our delta T is 50.5. So plugging that into the calculator, and remember that both numbers are in the denominator, so you're going to have to hit divide twice. Even though that's hard to do, you got to do it. It's divide, divide. So solving, we get C is equal to, big number on the calculator, 2.66. Can you see that decimal? 661556478 joules per gram degree C. Now looking at the problem, we notice here that our specific heat only has 2 significant digits. That means our second significant digit is this 6. The number immediately following it is a 6, which means we have to round up 5 and above, you'll give it a shove. So our C turns out to be 2.7 joules per gram degree C. 2 significant digits. Problem 3 is asking us to solve for mass. Identify variables. C is given, and it is 3.64 joules per gram degree C. We have our Q. The energy is 4,500 joules, and our delta T is given as 35 degrees C. So now we're solving for mass. So mass is going to be equal to Q over C times delta T. Plugging in our numbers, we see Q is 4,500 joules. Our C is the 3.64 joules per gram degree C. And our delta T is 35 degrees C. So joules cancels out. Degree C cancels out, and 1 over grams is going to be equal to grams, which is the appropriate unit for mass. Plugging this into our calculator, remembering that there are two things in the denominator, so you're going to divide and divide. 4,500 divided by 3.64 divided by 35, and you will end up with the number 35.32182104 grams, which is way too many significant digits. We look up and notice that our Q has the fewest number of significant digits, which also matches temperature. We need 2 significant digits. Our second significant digit is the 5. The number immediately following it being a 3, 4, and below. Let it go, so we do not round up. So we're just going to end it with those 2 digits. Our mass is 35 grams. Problem 4 is asking us to solve for delta T because we are looking for the final temperature. So you have to solve for delta T and then get to your final temperature. So our mass is given as 72.6 grams. Our C, specific heat, is 6.89 joules per gram degree C. Our Q is 8750 joules. So when we rearrange our equation to solve for delta T, we see that delta T is equal to Q over M times C. So our Q plugging in is 8750 joules. Our mass is 72.6 grams. And our C is the 6.89 joules per gram degree C. So joules is going to cancel out, grams is going to cancel out, and 1 over degree C is going to be equal to degree C. So plugging in here, our delta T turns out to be 17.4925132, and rounding that to 3 significant digits is going to be 17.5 degrees C. Now remembering that delta T is calculated as T2 minus T1, that means that T2 is equal to our delta T plus T1. So our T2 is equal to our T1, which was 31.4, plus our 17.5. So T2 ends up being 48.9 degrees C, and in adding and subtracting, you want to look at which number has the fewest digits to the right of the decimal, and all three numbers were at the tenths place, so leaving this number at the tenths place is appropriate, no rounding needed. So our T2 is 48.9 degrees C. I hope this problem solving has helped you.